Now the factor theorem says that if p of x is a polynomial of degree n, which is greater than or equal to 1, and a is any real number, then these two statements are true. Okay, but before we look into these statements, let's understand that by remainder theorem, we have found that the 0 of x minus a is a, and if we put that in place of x here, so if we find p of a, we will get the remainder. So we get the remainder by finding p of a, by putting the 0 of this divisor into the dividend. Okay, and that's why we can say that p of a will give us the remainder, which is r of x, and r of x is always going to be a constant of degree 0. It will always have a degree of 0 because the degree of the remainder is less than the degree of the divisor. And since the divisor is a linear polynomial, the degree of the remainder will be 0. Okay, so now let's look at the first statement. It is saying that x minus a is a factor if p of a is 0. That means if the remainder is 0. If the remainder, p of a gives us the remainder. So if the remainder is 0, that means if the remainder here is equal to 0, then obviously the divisor is the factor of this polynomial, right? So that is one statement of the factor theorem. The next statement says the opposite of it. Okay, the next statement says that if x minus a is a factor, if x minus a is a factor, if this is a factor, then what will be the remainder? Then the remainder will be 0. That is also true, because if you divide anything by its factor, you get a remainder of 0. So that's the two statements given here. Now the factor theorem does not have a proof in your textbook. So we need to accept it as this, okay? But we know that if the remainder is 0, then the divisor is always the factor. And if the divisor is a factor, if we know that the divisor is the factor, then we will obviously get the remainder as 0. Now, let's use this to factorize other polynomials. We will now use the factor theorem to factorize some polynomials of degree 2 and 3. So let's take this example from your textbook. Factorize y square minus 5y plus 6 by using the factor theorem. So this is a quadratic polynomial. Now we look at the factor of the last term, which is 6 here. We first multiply the coefficient of this with the last term. 6 into 1 is 6. And then because 6 into 1 gives us 6, we look at the factors of 6 here. And the factors of 6 are 1, 2, and 3. Also negative 1, negative 2, negative 3. Now we will put these factors one by one into this polynomial, quadratic polynomial, to find the 0 of this, okay? So if p of 2, let's find p of 2. So p of 2 gives us 2 squared minus 5 into 2 plus 6, which will become 4. This will become 4 minus 10 plus 6, and that is equal to minus 6 plus 6, and that gives you 0. That means p of 2 is 0. If p of 2 is 0, right, then according to the factor theorem, if p of a is 0, then x minus a is a factor, right? So because p of 2 is 0, we can say that the variable here is y, therefore y minus 2 is a factor of this polynomial. So we have found one of its factor, which is y minus 2. Now let's put 3 here in place of x. because we need to also check with 3 in place of y. So if we use 3, p of 3 also gives us 0. Now since p of 3 is 0, y minus 3 is also a factor of the quadratic polynomials. And quadratic polynomials can have at most 2 factors only. Therefore, we have found the 2 factors of this polynomial. So therefore, the factors are y minus 2 and y minus 3. Note that this polynomial can also be factorized by using the splitting method, by splitting the middle term minus 5y. So we can also use the splitting method. Now let us factorize a cubic polynomial using the factor theorem. For this, we again look at the factors of minus 120. Remember, we first multiply the last term with the first term's coefficient. So we have 1 into minus 120, which is minus 120. We look at all the factors of minus 120. And we get positive 1, positive and negative 1, positive 2, negative 2, positive 3, negative 3, and all of these are the factors. We start putting one by one each of them in the place of x here and find the 0 of this polynomial. So by trial method, we find that p of 1 will give us 0 in this case. So let's see if p of 1 gives me 0. So if I have to find p of 1 here, it would be 1 cube minus 23 into 1 square plus 142 into 1 minus 120. So that is 1 cube is 1 minus 23 plus 142 minus 120, and that actually gives me 143. I'm adding the positive ones. 1 plus 142 is 143, and minus 23 minus 120 is minus 143, and that gives me 0. And since p of 1 gives me 0, according to the factor theorem, if p of a gives you 0, then x minus a is the factor. Because p of 1 gave me 0, x minus 1 is a factor of this theorem, of this polynomial. Now we have found one of its factors. This will have 3 factors because it's a cubic polynomial. So let's find the other 2. Now to find the other 2, we can use 2 methods. We can use the long division method, and there is one alternative method that we can use. Let's first start with the long division method. So x into x squared gives us x cubed, and x squared into minus 1 gives us negative x squared. Now we will change the sign, so this becomes negative and this becomes positive, and this will cancel out. Minus 23x squared plus x squared gives you minus 22x squared, and 142x comes down. Okay, now x into minus 22x is going to give us minus 22x squared, and minus 22x also multiplies with negative 1 to give plus 22x. Now this negative becomes positive and this positive becomes negative. This will cancel out. So here we have minus 142x minus 22x giving us positive 120x. And now minus 120 comes down. So here we will multiply x into positive 120 gives us 120x, and 120 also multiplies with minus 1 to give us negative 120. And we will change the signs, and in this case both of them will cancel out and we will have 0 as the remainder. Again, the factor theorem tells us that we already knew x minus 1 is a factor, therefore we will get the remainder as 0. Now let's use this other method, which is a little shorter method than this long division method. So here I'm going to put x minus 1 here, okay? And we are going to get x cubed. So what should I multiply with x minus 1? Okay, let me take some other color. So we will have x square into x will give us x cubed, and x square into minus 1 gives us minus x square. Now again, I'm going to put x minus 1 again here. And now let's see what we can do. So I needed minus 23x square here. So what should I add to minus x square? I should add minus 22x square to get minus 23x square. Now these two terms I have got it from here. This new addition, I must get it from below. So minus 22x square, if I want to get it from below, I need to multiply minus 22x with minus 22x into x will give me minus 22x square, but minus 22x will also multiply with minus 1, so we get positive 22x. But here we need positive 142x. So what should I add here? I should add plus 120x, so that together they become 142. But this new addition, I must get it from below. So I'm going to put another x minus 1, okay, and get 120x from below. So the addition that I have done, 120x, I will get it from here. So x into positive 120, positive 120, there is not enough space. Positive 120, x into positive 120 gives me positive 120x, and x 120 into negative 1 gives us minus 120. Now we already have minus 120 here, so this is where we end the division. So you can see I get the same factors. The quotient is one of the factor and the divisor is one of the factors, right? There are two factors. So which is the same we get here. So if you see in these three terms, x minus 1 is common. So x minus 1 is one of the factor, and the other factor is x square minus 22x plus 120 is the other factor. Now the other factor that I'm getting is a quadratic polynomial, which I can further factorize by splitting the middle term. So let's split the middle term. We need to look into the factors of 120 so that we get 22 minus 22x in the middle. So which two factors of 120 will help us to get minus 22x? So we know that 12 tens are 120, and so I can have minus 12x and minus 10x. So addition of these two gives me minus 22x, and multiplication of these two gives me plus 120x square, which is what I get by multiplying the first term and the last term. So this is how we split it. We put plus 120 here and x square here, right? This goes into a bracket and x minus 1 stays here. So x minus 1 will always be one of the factor, but now we will regroup them. Okay, so here x comes out common and x minus 12 remains inside. and minus 10 comes out common, and x minus 12 remains inside the bracket. And so the three factors are x minus 1, x minus 12, and x minus 10. And this is how you factorize the cubic polynomials using the factor theorem. However, we have not used the factor theorem for the whole for finding all the three factors, because if we use that, we have to try and check with each of these factors and find the factors, which is not possible. So we found one of the factors, which is x minus 1, and then used this factor to find the other two factors by then using the splitting method only. Okay.